Hello students, let's continue with the chapter Central Tendency. Today we are going to continue with the chapter Mean. Now we are going to do the third method to calculate mean, that is step deviation method. Step deviation method is just one step ahead than the shortcut method. In shortcut method, our method stop when we find deviation. But in step deviation method, we find a one step ahead of these deviations and find these deviations up to their minimum terms. Now in individual series, this is possible easily when the items are at regular interval. But if interval is not regular, then sometimes this sum is difficult to calculate. Like in this sum, we have taken the difference is either 20, 30, 40, etc. It can be positive, it can be negative. Like we have taken 200 as assumed mean. When we subtracted the 200 from these terms, when we subtracted from 190, it is minus 10. From 220 minus 200 is plus 20. 160 minus 200 is minus 40. And 240 minus 200 is plus 40. Now we have taken these deviations to their minimum terms. We have taken a common difference among these deviations. Common difference among these deviations. So this is C, that is common difference. It is 10. By dividing these deviations independently, individually, we divide it with common difference and we get deviation at its minimum term, which is known as D dash. Like 20 divided by 10 is minus 2. 20 divided by 10 is plus 2. Minus 40 divided by 10 is minus 4. Plus 40 divided by 10 is plus 4. So when we are going to add up negative terms separately, positive terms separately, we will get summation D dash is equal to minus 3. So assumed mean is 200. Summation D, in the shortcut we write D, here we write D dash divided by number of terms. Multiply the common difference. If you don't multiply the common difference and here you write D dash, your sum will be wrong. So this is minus 3 divided by 8 into 10. By dividing this fraction, we will get 3.75. When we subtracted 3.75 from 200, our mean is equal to 196.25. Now the next series is discrete series. In this series, marks are given and against these marks, number of students, those who have scored these marks, their number is given. And the total data comprises of 50 students. Like 40 marks is obtained by 15 students and 5 students got 70 marks and 10 students got 50 marks. So in this case, we are going to take assumed mean from the X itself, from the marks. That is why we get average or the mean marks. Then frequency is there. Then we are going to subtract assumed mean from each X and we will get the deviations. Then we will bring these deviations to their minimum term. Here the difference, the step among the deviation is 10. 20, 10, 20, 30. So this way. So C is equal to 10. Dividing each deviation with 10, we get D dash. Like minus 2, minus 1, 0, 1, 2, 3. Now the next step, which is important in discrete series, we will multiply this D dash with the frequency. So this is minus 10, 7 minus 7, 7 multiplied by minus 1 is minus 7, 15 multiplied 0 is 0, 10 multiplied by 1 is 10, 8 2s are 16, 5 3s are 15. By adding positive and negative deviations separately, we will get summation FD dash, which come to a positive term, that is 24. And when we apply the formula, mean is equal to assumed mean plus summation FD dash divided by summation F frequency into C. So assumed mean 40, summation FD dash is 24 divided by 50 summation F into 10. and you will get the mean marks, that is 44.8, because the assumed mean is of marks, so the calculated mean is also of marks. Next, continuous series. In continuous series, class intervals are given, frequency is given. The first step is to find midpoint. If you don't find the midpoints, your sum will be wrong. So in class interval, before finding mean, we have to convert this class interval into midpoints and assume mean is always taken among the midpoints, not the frequency, because frequency just show the number of terms in a particular class. Like among 30 to 40, how many items are lying? 25. 40 to 50 and 20 to 30, how many items are there? 20, 20 each. So the summation frequency, the number of persons, the item in a data, is equal to 100. Among the midpoints, we taken 35 as a assumed mean. Then from every midpoint, instead of x, we will write midpoint. From every midpoint, we will subtract the assumed mean. So 5 minus 35 is equal to minus 30. 35 minus 35 is equal to 0. 55 minus 35 is equal to plus 20. Now we will bring these deviations to minimum term, that is d dash, by taking a common difference among the deviations. So it's minus 3, minus 2, minus 1, 10 divided by 10, 1, 30 divided by 10 is equal to 3. Now we will calculate fd dash. We will multiply d dash with the frequency. Minus 3 multiplied by 8 is minus 24. Minus 2 multiplied by 12 is equal to minus 24. 20 multiplied by minus 1 is minus 20. Same way 20, 20 and 15. We will calculate separately the negative and the positive deviations, right? So negative deviation comes to 68, whereas positive deviations come to 55. So the FD dash is minus 13. So assumed mean is 35. 35, FD dash is minus 13. This FD dash can be positive, it can be negative. Then summation F is equal to 100 and common difference is 10 in this series. So when you divide it and solve the fraction, it's minus 1.3. 35 minus by subtracting 1.3 from 35, we will get 33.7 as the mean of this series. So this is the step deviation method. I hope this method is clear to all of you.